Okay, thank you to be here for the lecture of today. Should be nice if I am able to. Yeah, now. Let me restart reconsidering this exercise. Look, calculate the plane to three. Is you have a three-dimensional tree, x, epsilon, x, y, excuse me, x, y, z, or if you don't like x, y, z, you can call with three different symbols. We have two vectors. No? Let me see if I remember well. Okay, two vectors, I see. V1 and V2 passing through point P. Again, you remember I invested a lot of time to clarify the concept. As you remember, at the beginning I told you, a point is in a vector. But last time we had the possibility, or the way to clarify that the vector is something more than a point. This means I would like to say that a vector can be seen as a point, but a point cannot see as an. Oh, well, it's a little bit confusing now. But the idea is the vector is something more because indicates the direction. Formally, let me conclude. So formally, we cannot distinguish if I don't say what is the point and what is the vector. Look here, V1, V2, and P. If I don't write anything around, you can say they are three vectors or they are 3 points. But I clarify V1 and V2 are vectors, it's written by vectors, and the point is P. This means P does not represent the direction. This is a little bit the difference without many other aspects to be clarified. Now, first of all, before starting with the calculations, in your opinion, intuitively, it is enough to define, or let me say to calculate, also to define a plane. I mean, is the problem a well-posed problem? The well-posed problem means, let me see, that it seems to be solvable. This means it seems to be, in your opinion, plausible that these three elements, two vectors and a point, should define or should be possible to calculate and play. Yeah, it is possible because intuitively means try to figure out. Look here. I have two vectors, V1 and V2. Doesn't matter how. You can play with two fingers to consider two vectors. It doesn't matter what. This is two. This means intuitively, if you have two vectors, you have two directions. Do you remember when last time we discussed, or we did the exercise with a line? A line could be defined using the direction. And intuitively, you can understand that in plane, just to figure out, let me say, orient the plane, it's enough to have two vectors. Look at it, just to figure out. As for a line, to orient this line, one direction was enough to remember this example. Now, in any case, it seems to be plausible to orient the plane using two vectors because we have two directions. In fact, the plane in the school can be seen in two dimensions. No, well, look here. One dimension, second dimension. Intuitively, this means we can see here one direction, second direction. Intuitively, just figure out. But of course, it's not enough. It's not enough to define totally a plane because I can consider the orientation. If I have these two directions, it doesn't matter which one, but I cannot assume that this is our orientation. That could be this, could be this, could be this, could be this, all parallel planes are generated by V1 and V2. Again, this this direction define infinite possible plane. So this means it seems to be well posed the problem. I mean, it seems to be possible to calculate the plane characterized by these two directions, V1 and V2, and passing through a point, because when I oriented the plane, and then this is enough to say it's here. So this is definitely our plane. It is enough. It is not necessary to figure out. No, it's not necessary, because we can reconsider the definition, and the exam we do the calculations to show me that you are able to calculate the plane. But why I invested this 10 minutes or 5 minutes orientation, well-posed problem, and so on? Because in math, as in system theory, but also, let me say, in the life, very important when we have a problem, this is also a problem, to try to figure out if the problem is solvable. If the problem in the sense, I mean, if in my opinion, the problem is solvable, then at least I can try, because I can make mistake in my figure out, in my intuition. But in any case, to solve the problem, to have an idea about if the problem is solvable, the meaning of the problem can help. In this kind of exercise, probably not much, because look, if I apply the definition, you can forget what I told you until now. But in order to be aware, in order to be, we will see in a more difficult problem, it's important to have an intuition. If it's possible to solve the problem, it's not possible to solve. For the exam itself, it's enough to apply the definition. But again, we are not here just for the exam. We are here to learn, and then the exam will be extremely easy. Okay, look at the first sentence. The first sentence says that our plane characterized by x, y, z. Why that x, y, z? Because x, y, z is the general space in which our plane is included. At the beginning, I mean, in the problem which I am trying to formulate for you, we can see that the plane, the life of the plane, is in 3 dimensions. A little bit strange this way to express, but it's clear that x, y, z are coordinate we know from high school, no? That define our dimension, if you want. In fact, all elements which characterize the plane are included in dimension 3. We can see here 1, 2, 3, the component of V1, and so on. Do you remember we cannot we cannot consider in a set of elements with different dimensions. Keep it in mind. A set of vector is a set if all elements have the same dimension, 3 dimension, 2 dimension, 1 dimension. Otherwise, okay, we can define whatever we want, but it could be that we cannot use. Believe in math, you can define whatever you want, but it's the meaning of the definition. The meaning of the definition. The positiveness of the definition, if I can use the definition. At the beginning of December, I told you already, I hold the lecture in 10 minutes theology. I will invite you. I already held 3 lectures. You can find in YouTube my lectures in theology. My theology is a bit strange. Last time was I told you, the mathematical demonstration of existence of God, not from me. It's not by me. The demonstration was from Gödel, a mathematician from Pittsburgh University, something like that. I don't remember. I think because theology, philosophy is close to math. Is no Professor Habermas is an emeritus professor from Frankfurt School. He's still active, but is emeritus, is more than 90 years old. Did you hear about him? Sociology, Aymal, I met in Heidelberg. And after I was student, um, after the seminar, the topic was Kant, die Religion in der Rolle der bloßen Vernunft. And nobody asked, no, I asked the question. And after after I finished the lecture, we met a little bit to discuss. He came to me and said, "Are you a student in philosophy?" No, I'm a student in system theory. And, okay, it's a new field of applied mathematics. And then he said to me, mathematician very often is good philosopher. Philosopher not always good mathematician. Okay, again, why I'm saying so? Because very important to learn, to approach this way to think, the way to think, really think in act. And then it doesn't matter if the definition of God, if the definition of something different. Okay, calculations. We have seen something similar when when we did the exercise considering the line. At that time, we have just one vector which generated the line. We come back on the line. Here, it seems to be that x, y, z, this plane which I have to calculate, is generated, if you remember the lecture last time, by two vectors, vector v1 and vector v2. But generating means, in this sense, that I have to multiply the v1, let me say, and v2 by two different parameters. This means independent parameters, t and k, which belong to R. Do you remember the concept of the parallelism? I define the parallel, again, the definition. When two vectors are parallel, or let me say, more roughly speaking, 1 to 1 is a vector, and all vector parallel to 1 to 1 is multiplied by t. This is the concept. Yeah. You can use whatever. You can use whatever symbol. Very important that you declare it is written that they are real, because you remember parallel means with the same direction, but means in the same time with the different direction, opposite direction, to opposite. This means that I am moving on this direction and plus, and in the meantime I am moving the other direction. Do you remember last time I told you about this element which moves on the line? Do you remember this? We come back on the line because probably can help to understand this. Plus a point, but the point is fixed. We don't have here parameters. This we can see now. What is written here? What is written here can be translated in mathematical language, because the plane x characterized by coordinates x, y, z, any x, any y, any z, equals, this means are generated by a combination, a linear combination of these two vectors. You remember the linear combination? We have seen the exercise. But should also include the point 1, 1, 1. We can see, therefore, that x, y, z, all points characterized by x, y, z, can be expressed, please pay attention, with this, let me say, two combination of two vectors plus a point for each t and k belong to R, because this t and k characterize this combination. Now, here, the formalismus now is better than last time. If you remember the identity principle, before the identity principle, I have to recall what is the meaning of this sum of these three elements. This means I have to sum the correspond. It's a vector here. This is a vector. Yeah. Characterized by t plus 3k plus 1 as the first component. The second component is 2t plus k plus 1, and so on for the third one. Third one is 3. We have here a vector, and on the right we have a vector. But this means if the left equals the right, I have to put equal all component of the left and on the right. This means x equal t plus 3k plus 1, y equal 2k, 2t plus k plus 1, and z equals t plus k plus 1. Now, basically, in accordance to the definition, somehow the exercise is already finished here. But if I write calculate, typically we intend an explicit expression of x, y, z. I mean, calculate means to do these calculations, but the meaning of the calculations are to express explicitly x and y, z. Somehow that I can figure out the plane. Here it's not clear what the plane is, because you remember we have two parameters. In this case, last time we had just one parameter, t, in the line, which play a role on the right part. This means it's not clear if I have to draw x and y, z. This is extremely difficult to draw. In general, it's extremely difficult independently of the parameters. You remember last time it was not so easy to see. But in this case, it's really impossible to draw. But look what I am doing now. T and K are parameter which characterizes the direction of this vector, and K the direction of the other one. What I can do is to explicit T, for instance, we can do it different way. The idea is to have an expression free from T and K. Why that? Because I need to see clearly expressions, or one expression, could be also two expressions. Remember last time we had the intersection, a line was an intersection of two planes, if I remember well. We will see now what happens. In any case, I have to have an expression free from parameter T and K, because basically T and K a parameter which of course helps to define the plane, but the plane is characterized just by x, y, z. It's in a set of points characterized by x, y, z. This means T and K can be seen as help parameters. This means if they help, but it's not intrinsically in the set of points. You remember the definition. The plane is a set of points. This means could be, I can obtain an expression without T and K. This means I have to try to eliminate, let me see, the parameter T and K from these three equations. It is possible, it seems to be at least theoretically possible, because we have 5 parameters, x, y, z, t, and k, or elements, and 3 equations. I don't know if you remember a little bit in high school these rules, but if you don't remember, it does not matter. Let me do the calculation. It's easy to do the calculation than to explain the theory. From the first equation, t is x equals x minus 3k minus 1. Clear. Math gymnasium. I plug in, or I substitute t in the second equation. This means 2 times t, which multiply, 2 times t, which is t is given by this expression here, plus k plus 1. Now, what do we have in this expression indicated by this arrow? We have one equation in which appear just the parameter as a parameter, just the parameter k. We can see here, no? What I'm doing here now? Instead of t, I write again the thing which I calculated before. Plug it in, just plug it in. Now, what we have here in the two last equality, we have 2 equations in which we have again four parameters. Excuse me, before we had the five parameters, now we have four, because one we eliminated. I repeat a little bit because it's easy to show the calculation than to explain, but to explain help to understand for next time. I explicitly calculate, let me say, express t from the first equation. I plug it in t which came from the first equation in the third one. This means the second and the third equation is free from t because I plug it in. Now, these two equations consist of four elements because t is not present. But I can, in the same way, here, calculate, for instance, you can choose whatever you want. This equation here, but you can calculate from this k. Look, k from the last equation is or equals x minus z divided 2. Why that? Because -1 is -1, it's 0. X, a little bit difficult to see, but it's not so extremely difficult because we have a -2k, we can see here, no? -2k. And you can consider here x minus z if I bring on the other part, on the right part z. No? If I bring on the left part 2k, I have 2k equals x minus z. This means I can justify this expression. Try to do alone. Immaginate it. Then I'm ready. Why that? Because I can plug in this expression of k in this equation here. Therefore, I indicate this equation with an arrow. And if you plug in here this expression here, believe me, I will obtain this expression, which characterizes my plane. To draw this plane is a little bit difficult. In 3-dimensional, I don't ask typically. If you have a computer, easy to do. But yeah, normally it's not so easy to calculate this. Let me propose for you. In the meantime, I have to do another call. In a couple of examples, I need just 2 minutes, but I propose in this context a couple of examples. If we repeat exactly now. Let me see. So difficult.
Ja, danke, das ist ganz gut.
Or better if I look in the exam exercise, so you were. I Okay, I have. Look at this. We will restart. Okay. Here. We realize that the exam now is easy. Okay. Look at this. I didn't show you the answer. Example exercise. I give you 2 minutes. In the meantime, I have to call before the telephone shut down. Find the line. We will start with the line, as I told you. LXY, characterized by coordinates x and y, passing through P11 with direction 1, 2. I don't know if you already did, but try with this. I don't think so. I come.
So mit anderen Buchstaben, aber wenn das auch S, also K, 2, rechts, bei 52 X, dann hast du Y drin, minus 2. Minus 2. Ja, man muss ja 2 X, minus 6. Ja, ich habe 2.
You solve? Not yet. Okay. This is typically easier or faster. It's not easier. It's faster than a plane because we have just 2 dimensions. This means the calculation is much less. Much less. Should I start with the solution? Oh, 30 seconds, think. It's good to think, so we can discuss. 30 seconds. First of all, it seems to be well posed. We have a direction. Doesn't matter what. It oriented already the set of points, a line, and then 1 point. We can see a little bit, I would like to say something more about that. A line is characterized by 2 elements, x and y, at least a line in R up to 2. I didn't put this formalism, but it's implicit when I write L of x, comma y. This means the line is in the room dimension 2. Of course, I can consider also a line in the room dimension 3. We did this, I think, last time. If I have another example, I try to do. And then we have the point P and the direction. Let me, should I start? Oh, okay. Definition. The definition says L of x comma y, in this case, because we have just L in dimension 2, equals point plus t, which is a parameter, which multiply v. Then I wrote here, for each t belong to R excluding 0 is in a discussion, because if I include 0 is not wrong, but it's not exactly aligned because I collapse in my point. You remember in some books they say a point is in a line and collapse it line. It's just in definition things. I think a student asked me what happens for t like 0. This way to write means excluding 0, but you can include because in a point is in a collapsed line. Do you remember? Yeah.
That's very important, but what if we forget to write this definition in the exam? So we don't
For me, it's not important. Just to, and the lecture, I try to be precise.
Yeah.
To discuss 0, if 0 is there, what happens? Collapse in a point. No, wie kann man sagen auf Deutsch? Ich bin keine Nervensäge. But I have to tell you in the lecture, in order to understand. In the exam, is in detail. Sometimes it's important, but I don't believe me. Nevertheless, thank you for the question, because we focus on the most important thing. We don't have so much time to really, we are not a course for mathematician, but I think how in the course of mathematician, I don't think so that it's probably in an oral examination to discuss, but because you have to do many exercises, not only this. Okay, the definition, I copy the definition. This means you can copy the definition, very important, from the data sheet. Very important. Everything depends of the definition. Also good in the demonstration of existence of God. Everything depends on how we image God, how we define God. And each definition must be useful. If I define God, God should do something for me. Otherwise, I don't need God. This is an interesting sentence. If you don't help me, I don't need God. But anyway, not only mathematics here. No? Now, in accordance with the definition, I copy now the definition with the structure which you learned here. No? This means L parenthesis, x comma y parenthesis can be seen as the set characterized by the general vector x and y. We can see that here, on this part here, we have a general vector x and y. This is our line. Because basically, in the line, try to figure out, can be seen as a vector, no? It's in a direction. No? It's not on this line. No? It's in a direction, basically. Equals P11. I copy what P is. P is 1, 1. Equals 1, 1. It's easy math. I think it's easy mathematics. No? It's easy. Well, you copy the definition. What have you to do? Plus T again. Very important, nevertheless, don't forget here T. No? This is in the specification that conceptually is important for each. For each is a very important quantificator. You know this word quantificator. For each. This means you can choose T whatever you want. And again, and student ask me, but for 0, I answer, if you don't like, exclude it. Because on a particular line, a point, which is in a line, in a particular line. Now, again, we have seen this exercise before. We have seen that x equal 1 plus k, because the left part must be equal the right part in accordance with the definition. Our line is characterized in this form here. This means x equal 1 plus k and 1 equal 1 plus 2k, because equals means left, right equals right. This means in accordance with the definition of the equality at the beginning of the semester. Do you remember with Zoom? What is the meaning of equality? Each component must be equal. This is the definition, our definition. To be precise, the corresponding component. we can see here x equal 1 plus t, y equal 1 plus 2t. And I write this here. Yeah, I rewrote again because a student asked me about the minimum of t, the meaning of t. Look, I put here x as a function of t, y is a function of t, because I tried also last time to clarify a little bit and possible application of this geometric representation. Could represent, you remember I told you last time, a particle which is moving with velocity equal 1 through x, and moving with the component y with the velocity equal 2. I don't know if you remember a little bit physics at school. This sentence here came, or this expression came from a question for a student. What is t? Can be seen, the application of this geometrical approach could be seen in a uniform movement of a particle in kinematic. In kinematic. How change the coordinate of a particle which is moving starting from the coordinate 1, 1. Last time I told you this, I think. I told you also last time, and to clarify a possible application. But with velocity 1, I mean, for t equal 1 second, for instance, if t is second, I have a deposition 2 because it's 1 plus 1. This means that the velocity is 1 with respect to the coordinate x. What happens here? I am starting from y equal 1 because at t equals 0, the particle is at y is equal 1. After 1 second, if t is second, if t is hour, after 1 hour, I have in the position y equal t equal 3, because 1 plus 2 times 1 could be second, could be hour. The velocity is 2, constant. Just to give you a feeling how I can apply this in physics, in kinematics. We are not here for this. But just to, otherwise it seems that, believe me, it seems that we are here to do abstract thing. We are here for abstract thing, but we try to apply this. Believe me, this concept here, together with all the concepts, I apply my work. I come from industry. I'm not an academic in this. I mean, I am here professor, but my career was in industry. This means I am happy to apply. Look here. Forget this at this moment, but I told you, I think also last time. I told you also last time this movement, possible interpretation. From here, as before, but a little bit easier, or easier, I don't want to say, a little bit, we can do now the calculation in somehow quickly, because we have just one parameter that disturb me in order to have an expression of my line. Is t. T is important, ask me. T is important if you want to apply in physics, for instance, assuming that t is the time. Please consider that the choice of t very often came from this time, the time, represent the time. Why I didn't put A? I can put A. But t recall also in a possible application. Now, what I'm doing here, for the first equation, I explicit t because I don't want to see what happens in time, because it's already here expressed. I want to see the geometric expression where I will move in time. This is a little bit the concept that we have in this expression. We can see the movement in time with respect to x, with respect to y. This means I can draw, or I can figure out, I can calculate the new coordinates over time. But the question was calculate the line. This means it doesn't matter with which velocity I am moving in terms of x, in terms of y. I would like to see the set where I am moving, independently of the time. Independently of the time. I'm traveling from here to Hanover. It doesn't matter the time, but I know that I'm going through this route. The route is here at the end, but it's easy because when I have a t, I plug in here. Because we are looking for the line. The line is the set of the point which I am passing through, if you think about the movement. Difficult? No, easy. Too boring? I try to do it with something more complex, no? Yeah, here we have a possible representation of the line. We can see exactly what I told you. Here is the generation, and then I will move parallelly in order to get the specification, no? Because the specification was 1, 2, no? The point, let me see, I show you better if I find something right. I try to interpret this picture. No? We have a direction. Excuse me, the direction one was 1, 2. I made mistakes. Please pay attention. Everything is correct, but I told you wrong. The direction is characterized by the vector v. It's the direction this one because we have the component 1 here, and here we have a 2. I didn't put, but it's easy to see. No? 1, 2 characterize is the vector which characterizes the direction. But this line here, or better to say, the line characterized by this orientation should passing through 1, 1, this point here. This means I have to draw parallelly this line here. The red is the correct one, because you remember I told you before, with vector or the vectors, I can orient my object, and then I move parallelly. Do you remember today with the plane? This is a little bit what we can figure out. I didn't ask any graph in the exam, but here in order to understand better, I didn't ask because sometimes it's not so easy to draw. The red one
So,
is the line which we are looking for.
yeah,
It's okay. Huh? Another example is size now.
so if you want to, well, also would be just trying to write y.
Is this enough to write y equals 2x minus 1? You don't have to graph anything. It's here in order to understand better this concept. We have already seen a similar example last time, but now I will try to emphasize a different way to solve, even though I told you also last time.
One question, how did you then finish the exercise we looked on before, like the number 2 from our lecture?
I have to look because I don't remember. In the slide you intend. Let me open the slide. In the lecture number 4.
Yeah, lecture number 4.
Let me look because I don't. Yeah. Now.
Yes, that one.
This we finished. No? This is the play. Isn't a plane this expression, because we have, let me say, because your question is why this is the plane. I mean, the calculation is ready, everything seems to be I don't see any error. But now if I try to explain this the question is why this is in a plane. Now again, your question is why this is in a plane.
y minus that plus x, did you just put the point in or what did you?
Okay, to verify. Yeah. To verify this is, let me say, I will consider this verification a little bit later or during the yeah, you understand your question. I mean, you want to, you ask me, is this the right plane? Your question is this the right plane? For instance, as you propose, I can put this value here. I can put this value here in the corresponding coordinate x equal 1, y equal 1, z equal 1. I have to verify if this left part equals -2.
Yeah, I think I have to check with this one. I haven't answer the day.
I mean, the point 1, 1, 1 belongs to the yeah. You can see that you have on the left part -2. If you plug in, let me say this 3.
On 3 plus 1 minus 3 plus 1.
We will go in depth on this question here exactly now because you provocate me now. Try now to think how I can demonstrate. It's okay. The point 1, 1, 1 we have seen does belong because satisfy the condition. Satisfy the condition means is exactly the belongingness. The belongingness. Now the other test which we can do, theoretically I can ask at all also in the exam, if this, for instance, direction generates this this plane, and in the meantime, this direction generates this. This could be interesting to demonstrate. I will tell you in a few minutes. Let me do the exercise which I am trying to propose in order to answer this question here, because about the point you understand or you agree that 1, 1, 1 is included here, but the condition was 3. This plane here is generated by the vector 1, 2, 1 and generated by the vector 3, 1, 1. And then you ask me, are you sure? Because at the end, in math, we have to verify if the calculation is correct, if really this plane represent or reflect, or yeah, let me say, generated in particular here by these two directions. Let me come back to this example, and then we will reconsider to verify also this. Look.
Why to insert t into the y equation and then to solve it to continue this that, because that's the part where I got lost.
A little bit more complicated, I think, if I understood well what you
Maybe I can just figure out.
let me explain, let me do this, and then we will reconsider this. Look at this, and then we will discuss. We'll discuss again what we did until now. We have seen also such kind of example. Huh? We can see that here we have a point P, and we have to calculate the vector, a plane orthogonal to a vector. We have seen already this. And I tried I did last time in two ways. I don't know if you remember. But the fastest way to do is this way. Why that? Why in this expression, and then we will come back on the. Why in this expression I summarize with this expression exactly this sentence here. I mean, this sentence here plays calculate. I didn't put calculate. Calculate the plane. 4 means that P belongs to the plane and orthogonal to this vector. I summarize this sentence in this form. Think about that. Why? Because in this expression, this mathematical expression, I have the two conditions. It's clear that we have the two conditions because if h of x, y, z equal p, this means p belong to h because the condition is satisfied. This is quite abstract, but quite clear. It seems to be abstract. No? Does this sentence here calculate? No, I simplify. Calculate plane for p means in which considering p that belong to the plane and orthogonal to this mathematically means this expression. Why that? Equal 0 is related to the scalar product. Remember the dot product to be precise. No? The orthogonality defined in terms of scalar dot product between what? V, which is given, let me say, explicitly, we have three values, and what? In the plane, please pay attention to the words. The plane characterized by x, y, z, but the plane includes p, which is given. Seems to be too abstract. The question is why the plane includes p? Why does the plane include p? Because for h of x, y, z equal p, we satisfy 0 because this is 0. It's too difficult to see probably. No? It's too difficult. Okay. If I have two vectors, v1 and v2, they are orthogonal if and only if, no, according to the definition, if the dot product is equal 0. This means equal 0 we can justify because we have here in this sentence we want to have an orthogonality. Now the orthogonality is not between two vectors, it's between one vector and something which is in a plane in which we have a particular point. First of all, the proper formulation makes sense, no? Because you remember last time I told you, if I have a direction and I say that the plane is orthogonal to this direction, I already oriented the plane. Could be this, could be this, could be this, could be this, but it's oriented. Oriented is clear what I intend. And then if I have a point, it's fixed. This means the solution should come. It seems to be well posed, the problem. Well posed means makes sense, and I hope to find the solution exists. Also, the problem could be also well posed, and at the end we don't have a solution. And anyway, we have the sufficient elements to demonstrate something without contradictions. Look here. Why is now the difficult is to understand why this part here formally reflects that the plane in which P is included is orthogonal to V. This is the difficult thing to be interpreted, right? V is given, no problem. No? I recall the definition of what? Orthogonality between two elements. We have seen two vectors, but here, nevertheless, we have a vector because all points which belong to the plane, point is also a vector, do you remember? Dot V equals 0. Why? The question is why this expression here represents our plane in which P is included. It's easy to see because here, do you remember, is X, comma Y, comma Z. Probably can help this. X, comma Y, comma Z. And here is 4, 1, 0. But it's clear if X equals 4, Y equals 0, Z equals, Y equals 1, Z equals 0. This means if P belongs to H, the equation is satisfied. Because the dot product is 0 because this point belongs to P. This point here, when this point belongs to P, when this minus this equals 0. Let me see if I have another example. But let me conclude this. It could be that this is difficult, to see these two conditions in this expression or in this expression. This expression here summarizes the two conditions because we have the belongingness and the product, or the dot product. If you don't like, I have an example with the line I can draw. Let me do the calculation, then we will come back on the line. Let me do assuming that we understood. Now it's easy to do the calculation because this minus this is this. You can do the calculation in vertical. You can do the calculation in horizontal. Until now, we have seen in vertical. Because the vector can be represented in column form, but can be represented also in row form. No? From here to here is clear. No? Doing the calculations, I have the plane. Why I wrote here B? Because if you want to apply the definition, one of the definition which you can find in the line, this is the parameter B. Do you remember? I did also this calculations using a different let me say definition of the plane. But this I like a lot because in this condition here, this mathematical equality, we have this both condition, the belongingness of P and the orthogonality of the plane which I'm looking for, the orthogonality with respect to V sets. Because P belong to H, because if H equal P, we can see here, if X equal 1, Y equal 1, Z equal 0, it's satisfied. This means P belong to the plane. Think, 1 minute, and then I show you an easy example in which I can draw something for you in order to clarify. Here it's a little bit difficult to draw because in 3 dimension, let me. One, I would like to do an observation, then we will do another exercise before discussing everything. Look at these coefficients. 2, 2, 1. 2, 2, 1. 2 multiply x, 2 multiply y, 1 multiply z. Look at this. 2, 2, 1. Meaning, I will come back on the line. We can see very well the meaning. But the meaning is that these coefficients here are exactly the same as here. We have observed this. This means that the coefficient which we have here states the orthogonality, and let me say we can say that they represent exactly the orthogonal vector to the plane, because this plane here is in a particular vector which is passing through P, but is nevertheless parallel to the plane which is passing to 0. I mean, if P, please pay attention, if P here is 0, 0, 0, we have a B equals 0. I don't know if it's clear because P is equal 0. We have the same calculation, but we don't have 10. We have 0. I don't know if this is clear what I intend. This vector here, as I told you when I figure out the exercise, is orthogonal to all parallel planes. I can consider any kind of P, any kind of P. We'll change just this parameter. But these coefficients here, these three coefficients, is exactly the same like this. If P equals 0, you have a 0 here. Let me show everything again using the line. So we will reconsider in an easy way. Look at this exam exercise. And then we will recall again this everything. This I can draw because we have just 2 dimensions. Find the line L as a function xy such that P equals x1 y1 second it goes it's a little bit symbolic. No? X1, Y1 is something. Could be 1, 1, could be 3, 2, everything. Well, it's given. X1, Y1 belong to the line, that X1, Y1 belong to the line. I give you and the vector V orthogonal to the line is similar as before. I didn't specify the point, but assuming that I have the point, x1, y1. And as before, I define and I give you a vector V orthogonal to the line. Before starting with the calculations, in order to figure out what the problem is, you don't need to do the graph in the exam, but can help to understand what we are doing. And with this graph, I am sure that we can understand better what happened in the plane. But to draw in the plane is extremely difficult. Look at this representation. We have the vector V 1, 2, x equal 1, y is equal to. This means this is the vector as the vector we have the direction. We have seen until now. Right? Is the point 1, 2, but characterizes in the direction. This direction here should be orthogonal to our set of point line, set of point line, and set of point. If you read again the sentence, to this line should or must belong P x1, y1. You can keep whatever you want. Let me fix here x1, it seems to be here, y1 here, but could be also whatever in where you want. But in any case, passing through this point here, or if you like this point here, or if you like this point here, doesn't matter where, whatever you want, we have just one for each given point, orthogonal to this. This you can figure out. In this case, why I put x1 and y1? Because if I put x2, y2, we have another line or orthogonal to v, but parallel to this. Try to figure out. As before, we have a plane characterized by an orthogonality, but also all parallel planes are characterized by the same orthogonality. We can interpret this picture now. You can consider different point. This means I will move parallel this line. Try to think about it, independently of x1 and y1. Therefore, I put it symbolic x1 and y1 because whenever you want, the red line will move. Try to think about it. In the exam, you don't have to draw because you don't have time. You have to understand better. I need just a calculation. Now, we try mathematically to interpret what we have here graphically, which basically interprets this language here. It's just in a language. Typically, I'm the guy which I don't like it to graph because I'm not able to. I try to imagine, yeah, but to graph, I'm not so good. But some students or some people like to see. I'm more abstract. Therefore, you remember I told you before, P minus H in the parentheses dot V equals 0. I see very well does P belong to the plane without drawing. Believe me, to draw in 3 dimensions is terrible. Here we can understand a little bit better. Let me go ahead. Do you have a couple minutes more, or we are tired? We have one block here, sure. And then I give you exercise at home, the exercise which proposed your colleague or our colleague. We am here to learn. Look now, exactly the expression we will discuss about, but now in 2 dimensions. Let me see if I am able to explain. Okay, this language here, which seems to be understandable, okay, not much because of orthogonal. If you speak with Ellen, my wife, you understand not because she's moving from the learn and my mind. But anyway, if line belong for in complex. But anyway, assuming that we understood from here to here, okay. Now this language here is exactly the same expression. It seems to be difficult. I try to explain. Once we understood this, then we replace P with comma parenthesis x1 comma y1 parenthesis, and then we proceed. Of course, V must be also must be considered equal 1 and 2. Why this expression? Translate what we have here. For each P, I agree that for each P, the orthogonal is given because it doesn't matter what I right here, I impose to 0. For each p, I can write here, for each p, I didn't put, but it would be nice if I could. I mean, this condition must all, but to say for each p. I'm waiting for you because and you agree that for each x1 and corresponding y1, we have a parallel line, the red line, which are orthogonal to the line here. It's what I want to obtain, because calculate this. This means the red line is what I want to obtain. But it doesn't matter which kind of x1, which kind of y1. For each x1, y1 exists. But this is the well-posed problem. A line which is orthogonal to this direction. Could be this, depending on x1 and y1. This language here, this graphical language, we translate the text in the graphical form, can be summarized mathematically so. Here's more, let me say, geometrical language, here's more mathematical language, in which I summarize the graph. Because I say that all red points, this pattern here, look here, all red points. Because here I can write, I didn't write, I told you, for each x and for each y. This means for each line, anyway, this condition must be true for each x and each y. Which belong, in which p belong to it. The line. I don't know if it's visible from here. Because if L of xy equal p, the condition is satisfied. This independently of the orthogonality is correct. I mean, please pay attention. When this is 0, we have equal 0 independently of the orthogonality. Did you agree? This means if I look just these conditions, could be this line here, the orthogonal, could be any other line passing through this point. Again, if Lx, y equal p, this means that p belongs to the line. If p equal L of x, y equal p, or viceversa, this means 0. This means the condition is satisfied independently of the orthogonality, because it doesn't matter what we have here. This is 0. This means any line passing through x1 and y1 of the point P that satisfy equals 0. But then, together, I meet another condition. Dot means I emit another condition. That these elements here, all points here, this general vector here, dot v must be 0. This means in this sentence, I summarize exactly this picture here in which the red line is orthogonal to the blue. The rest is calculation. Before you go, I give you the exercise. The calculation is extremely easy because now I put x1, y1. I do the algebraic calculations, and I will obtain the line. But of course, I didn't give you x1 and y1. This means everything depends on x1 and y1. Let me show you quickly. Here I replace p with x1, y1. Easy. Because P was x1, y1, right? P was x1, y1. This means I plug in the definition. Yeah. Then I do the difference. X1 minus x. And here we have y1 minus y. This difference here is calculated here. Excuse me, here. The difference is here, no? Each component. Then I do the product. This multiply this plus this multiply this, according to the definition. Then it's just algebraic. This means 1 multiplied x1 minus x is this 2 times y1 minus 2 times y. Here, I bring on the right part everything which I should know. x1 should be given, or the y remain x1. y1 should be given, or the y remain y1. I call here b. Why that? Because I told you, depending on x1 and y1, I have a different red line. But nevertheless characterized by orthogonal vector 1, 2. Exercise at home. Question here? Oh.
Why is it minus?
I hope no mistakes. I hope no mistakes. You are right, you are right. Plus x1 should be, excuse me, plus u1. Let me copy, let me correct. Yeah, yeah. Thank you, thank you. Thank you. Error. Don't trust the professor who doesn't make mistake, no? So, no? No, that was correct. No, it was correct. Why? It was correct, right?
I have.
No, it was correct. Excuse me, it was correct. What is wrong? I mean, to be more precise, this means something like that. No?
Okay, sorry.
Now, no? Now it's correct. Now I clarify what I intended, because B with is strange. This means is confusing. You are right. This is clarify everything, I think. No? Which this you understand what I intend? This should be called B now. This should be called B. Excuse me for the confusion. This is not exactly B. Minus B, right? Let me write minus B. Now you agree, no? Now you agree.
Yeah.
At home, please play at home. Try to verify. Let me upload. Next week we will go ahead. No? Your question. Try to think how to verify that this vector and this vector generate this plane here. I mean, to verify is the calculation. If I give you this, the content, I give you this, and I ask, please verify that this vector here, this plane here, is generated by vector 1, let me say, and the vector 2. Exactly the content. I give you this plane. Say now the question is verify that the vector 1, 2, 1, and 3, 1, 1 generate the given plane. Try to think about it. Next week we will discuss together. This was a little bit your question, because the point P belongs is easy to see, because we verify, we did plug it in that left equal right. Think about now, not only for P, we already discussed. I give you this. Please verify that's vector 1, 2, 1 and vector 3, 1, 1 generates vector. Let me see if I forgot to say something.
Yeah, so my question is actually, yeah, like I didn't succeed to solve K to the same solution we had, but I managed. I just have, that was my question too.
Think about this problem here. It's interesting. Can help what we did until now. What does the vector 1, 2, minus 5 is orthogonal to the plane. Remember, we discussed this. The vector 1, 2, minus 5, we discussed this, is orthogonal to the plane. Think about now to verify. I already gave you an indication. We will discuss this week and we will go ahead. No? Other questions? Thank you really for the active participation. I like this. If I make mistakes, correct me. Nobody have the truth. In any case, not me. Thank you.